Hi there, it's Marcus here. I want to talk to you about the first week's reading. It's an essay by David Christian called World History in Context. It's very much a map, and that word gets used in this reading very significantly, but it's a map for the course and the way that I've approached world history. So it's a reading that does cause many students some headaches. It causes headaches because it's complicated. There's many things going on, so I want to break it down for you so that you can more comfortably negotiate the reading and come to understand its significance but also its elegance. For me, it is a deep and beautiful piece of writing and thinking. Writing and thinking go hand in hand. They support one another. Writing helps you think clearer. You need to think in order to express yourself through writing. So here we begin the course with what I consider a deep and beautiful piece of work. Now, I've referred to it as an essay, and it is. In every way it's an essay, or to use the French word essai, which means to an attempt. It's an attempt to do something. It's an attempt to make a broad and comprehensive argument. So it's an argument. The whole of this essay is an argument, step by step, link by link, logic by logic, leads from one thing to the next. So you need to understand that it's a deep essay, it's a beautiful piece of writing, and it's also making an argument. Okay, and what's it arguing for? Well, it's arguing for an understanding of world history, of how to do history within the context, not just of human condition, but of the cosmic condition. The essay falls into two parts. It's an outline of the key ideas already touched on in my introductory webinar recording thing. I'm using webinar technology, which is why I keep referring to it as a webinar, looking at complexity, energy, and collective learning. First 10 pages of the essay deal with the logic for why these three things are the key drivers that Christian has chosen to focus on. The second half of the essay offers us, should I say, a thumbnail history that concludes with a summary of world history's significance as a mode of historical inquiry. Like all good essays, you set the scene. So for us, we need to understand, I guess, what history is. History enables reflection on the past, the present, and the future. History is always present-centered, present-focused, because I guess the questions that we struggle with, we often look to the past to understand, well, how did other people experience this? So history is a great story, a ripping yarn at one level, because of course we can focus on exciting moments in history. But the large or the broad sweep of history is slow, developmental, and definitely not exciting in the way that, let's say, the French Revolution may have been exciting, or great battles and great warriors and so on. They are the things that make history come alive, but we must remember that most of history was filled with people just like you and me. Very special, of course. My mum always tells me I'm special, but also at another level we could be classified as ordinary human beings. So I have to say that history is all about us. As David Christian says on page 1, which is page 437, one of the virtues of world history is that it can help us see more specialized historical scholarship in its global context. Now, our species can appear to be insignificant on a cosmic level or scale, and this is a problem for some, and it's certainly a problematic that Christian raises. So, context. Well, Christian wonders, what is this context for world history? Context for Christian means what is the intellectual and the disciplinary context. The intellectual context is about the kinds of questions that we, world historians, ask. The disciplinary context is about the kind of knowledge areas, the subjects, you could say, that we turn to answer those questions. In traditional history, we perform historical research and we study written records of one form or another. Sometimes historians consult archaeologists. History itself, the traditional history, is divided up into many sub-disciplines such as economic history, which uses statistics and economics, art history, which interprets visual art and draws on written records, letters from artists or whatever. Music history studies musical scores as well, again as written records like letters and print matter from the period and so on. Now, the mission statement that David Christian gives us on the second page of his essay is the following. One of the aims of world history is to see the history of human beings as a single, coherent story. Now I'm going to paraphrase the rest. It's as concerned with non-literate communities. That means the people who are often left out of or have just footnotes in history. And it's also interested in describing the historical trajectory that is shared by all humans, how we came from the Paleolithic, from those early hominid periods, to be this complicated, messy, creative, perhaps pathological species that we could say we are today. That's the trajectory. So, and what is his conclusion? Understood in this sense, world history is about a particular species of animal, a species that is both strange and influential. Okay. Now, Christian restates this with considerable power at the end of the essay. So, what's the approach, and where does it lead us? Well, world history offers us a natural bridge between the history discipline and other disciplines, such as cosmology, which he draws a lot on in this particular essay, but also biology, which also gets much more than just a footnote in this essay. So Christian's argument is the universe of contemporary cosmology has limits in both time and space, but it's still huge. It's big, as they say in the Hitchhiker's Guide to the Galaxy, so huge that it can make our species and the planet we inhabit seem insignificant. And that, for some, is quite disturbing. The approximate age of the universe is 3.8 billion years. That's me rounding off that lovely figure there. All in all, it may seem that our Earth and our species have no significance at all in modern cosmology. So this is one of the tables that Christian offers us, looking at the chronology of the universe across 13 years. And you can see that modern industrial societies have been around for about 6 seconds of that 13 years, and the entire recorded history of civilization has been around for about 3 minutes. And so you get a sense of scale, of proportion, puts it into proportion. The spatial and temporal maps, okay, so this is a but. That might not be the whole story. The spatial and temporal maps of modern science are not the only maps. Note I mentioned maps earlier. Other maps tell different stories. Maps are ways of making sense of our context, we might say. Christian offers us the map of complexity. Instead of comparing different objects by their size, this compares them by their degree of complexity or order. Now, Christian notes that order is rare, and its opposite, disorder, is much more the common state of the universe, and that this play between order and disorder is one of the hallmarks of the cosmic context. As Kaufman notes, the maintenance of order requires that some form of work be done on the system. In the absence of work, order disappears. So this kind of work may be nuclear fission in a star, or it may be an animal like waiting in hiding to leap upon another creature, or it may be an animal digging, might be single-celled organisms photosynthesizing. That's all work. Or it's you and I having to go to the office and earn our crust. In the absence of work, order disappears. If we don't have the energy source that work gives us access to, we're in a problematic state. So understood in this way, the second law, and I've added of thermodynamics, seems to mean that complex structures from stars, starfish, can exist only if they can tap into a constant flow of new energy. Sorry about those blings. I didn't turn off the internet before I started making this recording. I'm going to pause the recording for a second. I'll be back. Here I am. So David Christian spends quite a bit of time talking about the second law of thermodynamics, and it causes quite a few students to get confused or overwhelmed. Basically, it means that when we've got energy, it leaks out of the system. It doesn't disappear, but it becomes inactive or dormant or static within the system. And basically, it's one of those laws that determines how we experience being or existence. So simple structures, such as a star, are easier to create and maintain in the cosmic sense, because they do not require such huge energy flows. The star is releasing energy, it's chewing it up at an extraordinary rate, and yet it is an essentially simple process of burning up hydrogen to create helium and ultimately a carbon core, which will be one day dead and cold and float off into the cold stretches of the universe. Very dramatic story. So over 13 billion years or so, and we've added a 0.7 to the 13 billion that Christian was writing about in this article appeared in 2003, but essentially it was written in 2001. So since then we've added another 0.7 of a billion years to that, but over these 13 billion years since the universe was created, complex entities have appeared, and many scientists have argued that the upper threshold, and this is really important, of complexity has slowly risen. It's important because, at least from our human perspective, it's us pushing that upper threshold forward. So what seems to happen then, according to Christian's argument, is that where large energy flows are available, they can sometimes bind independent entities. They pull them together into newer, more complex structures. Just as gravitational energy for simple atoms at the beginning of the universal, our cosmological story, at the beginning of that story, hydrogen, for instance, was fused into more cosmic complex elements. Okay, so now we turn very much to cosmology, to the work of Eric Chesson, for instance, whose book is in the library, by the way, and this question of complexity is important because it helps us assess how beings like human beings, animals, single-celled organisms fit into the cosmic story. We can assess it by the level of energy required to sustain high levels of complexity or life. So Christian, at this point, has identified two major players in the cosmological story or context, and that one is complexity and the other is energy. Okay, these are biophysical in nature. So here we have his second table, which gives us a map of energy. And so we can actually assess, okay, how much energy does the galaxy need? Well, it needs 1 unit. How much energy does the society need? Oh, it needs 500,000 units. Why? Because it is more complex, much more complex. Brains are also complex. The brain inside you and my skull is chewing up about 150,000 units of energy. So please note at this point, just as an aside, that you don't, oh, what's that? Yuck, go away. Sorry about that. Please note that you should not cut and paste tables into your essays. All right? Because there are always students that get very excited by these tables. You can speak or write to them, but don't cut them, paste them, and put them into your essay. Going on there, Christian is implicitly drawing on systems of theory which posit systems within systems. Okay, so systems theory is a new, relatively new science, and it suggests that there are different orders of scale within which, let's say, you or I live, within which any entity within this cosmos resides. So there are galactic systems, there are solar systems, we have planetary systems, we have biospheres within that system, we have biomes within those, the singular biosphere it should be, and we have various other forms of systems. There are economic systems. Our own body is a system in itself, and so on. So we have systems within systems. Now this is implicit to Christian's work, but I think it's very important to actually understand, because it helps us understand how he can change and work across scales. So complexity and fragility is a very strong theme in this. Fragility comes because of the second law of dynamics, working on complex systems. There is a clear hierarchy, Christian would argue, of complexity, at which human beings are at the top within a historical perspective, because world history is all about us still, just as history is. Okay, Martin Rees, now who's he? You might be saying, well, he's actually the Astronomer Royal, or he was. I haven't checked to see if he still is, in Britain. So he took over from Stephen Hawking in that position, actually, and he's written, "A star is simpler than an insect." Okay, this catches many a student's eye. It's bewildering at some levels. It's also exciting because we're starting to think differently about the things that our world and our cosmos have within it. So yet a star will live much longer. Why? Because a star is simple. Complex dense energy flows come with fragility and rarity, and they all seem to go together, as he says, as Christian observes. So we live relatively short lives in the cosmic context, just like grasshoppers live short lives in our own human context, and it's all to do with levels of complexity. So if we rank the contents of this universe not by size or age but by complexity, we find that living organisms loom larger than they do within the modern maps of space and time. So maps of space and time don't help us, but maps of complexity do. Okay, so Christian is offering us a new measure, and what do we measure? Well, we measure the universe's creativity. I love that idea, the universe's creativity. All that we have experienced in this universe over those 13.7 billion years, we could say, have been and are ongoing experiments in order and complexity. So the biophysical context, Christian has just given us the rules that living things need to play by to survive in this universe. Those rules are linked to the second law of thermodynamics and complexity and energy. They involve access, as I've just said, to energy and how we manage this complexity. Now he suggests a third element. And this is key to our particular species, but builds on how organisms in general have evolved over time. How do we manage change? Changes in our environment? Well, we adapt. Organisms have shown an incredible ability to adapt, and when they cannot adapt, they die. End of story. We can see this in societies as well, in civilizations. Angkor Wat have failed ultimately to adapt to the demands of its environment. They also failed to adapt politically. They were a hierarchic, disciplined society that was unable to respond to changes in the political contexts in which Angkor Wat as a civilization had flourished in earlier centuries. So let's move on. So one expression of complexity of living organisms is their superior ability to adapt. Okay, adaptation enables living organisms to find more and more ways of extracting energy. So it's still all about energy, and of course it's also about complexity. How do human beings, Christian asks, fit into these maps of complexity? He goes on to say Chaison's calculations suggest that they are central. In the course of 200,000 or 300,000 years, that's we, have learned to tap larger flows of energy than any other organisms on the planet, on Earth. And this suggests that in some sense they are more complex, but not necessarily more physically complex. This is now where we separate the biophysical from the cultural or social, where we separate the biophysical sciences from the human sciences, of which history is one. So he asks then, what explains this difference between humans and other living organisms? What's the adaptive mechanism? Well, natural selection starts it all off. And that's the Darwinian understanding, that we evolve and that the fittest or most appropriate adaptation in any context will give it a biological advantage. The second adaptive mechanism Christian identifies, is that of learning. So learning is limited in pre-human species to individuals. And he spends quite a bit of time talking about chimpanzees not being able to pass on the lessons from one generation to the next. Symbolic language is the key, is what makes the difference. Symbolic language allows human beings to learn collectively. Symbolic language allows us to store information, first in memory, in the collective memory of a tribe or a group. That becomes what we call oral tradition, and then, of course, in text, and now, of course, virtually. Symbolic language made available to humans a third adaptive mechanism, which Christian calls collective learning. And this gave us an edge, an evolutionary edge, an adaptability edge. Humans no longer function just as individuals. Almost every object or order we use today represents the stored knowledge of previous generations. Okay, language links individual humans into large, evolving structures that we refer to as societies. This is where history, of course, really comes into its own. Just as individual cells once combined into larger, more complex structures, okay, so now we combine culturally, okay, culturally, not physically, into larger collective structures. Collective structures similar to the hive of the bee or the nest of the ant. Whereas genes could pass on certain learnings, and they did so very slowly, knowledge can spread much more rapidly than genes. Okay, so he's talking now about cultural adaptation and the fact that it is cumulative and that it accelerates. Very important to understand our own context today as global citizens. Here we have an entirely new mechanism, Christian argues. Okay, and it will swamp or make unnecessary genetic mechanisms in their own right, which he points out evolve at glacial pace compared to social learning or collective learning. So this has given us astonishing ecological power, okay, based on the accelerating capacity, okay, to find new ways of extracting energy and resources from our surroundings. It is collective learning that distinguishes human history from natural history. Collective learning ensures that human history, unlike that of other species, is a process of accumulation and acceleration, and it is this process of cumulative and accelerating adaptation to the natural environment that is traced in our subject. So what does he think about all this? Well, all in all, collective learning is so powerful an adaptive mechanism that there is a case for arguing that it plays an analogous role in human history to that of natural selection. That's really important. So perhaps collective learning, he says, should be central theme in any attempt to weave a coherent account of world history. So, having got to that point, he then tells us a little story. He gives us a thumbnail history of humanity. Okay, so page 447 to 452, he maps out the human story. His focus is on adaptation and complexity and increasing complexity, and the measure is our increasing capacity to extract energy from the environment. So he gives us this wonderful graph, for instance. So we can see the energy consumption per capita in different eras, and we can see how astonishingly rapid has been the increase. Something new. Christian says, well, there's something new. We are something new. Human history marks something new in the history of our planet. It's not natural history anymore. We're not studying the dinosaurs or anything else, or the megafauna. We are studying a social or a cultural species. Now, he gives us a lovely analogy. This is a beautiful paragraph, or no, it's not a paragraph, it's just a short descriptive section. Like campers around a campfire, he says, we live in a cold universe near a source of heat. And it is this colossal energy differential that sustains complexity on Earth. The torrent of energy that pours from the sun into the icy surroundings of space provides most of the energy needed to support our biosphere. Yes, so it's this image of us as campers in a lonely universe. Are we happy campers? Well, we're not sure. Today, question of scale, humans may be controlling anything from 25 to 40% of the energy derived from photosynthesis and distributed throughout land-based food chains. That's a huge amount, and some people argue that we're actually controlling larger amounts than that. So the human footprint is immense. Human activity, particularly human activity in the last 2 centuries or so, will be visible on the scale of 1 billion years, he says. If paleontologists came onto this planet in 1 billion years' time, they would notice something impacting on everything at this time. Major extinction event. So human-like complexity is rare. Christians suggest that this kind of power inherent to collective learning is very rare, even on a galactic level. Why? Mainly because we don't know any other any civilizations anywhere else yet. If the evolution of creatures capable of collective learning was unlikely within the frame of planetary history, he says, it may even be more unlikely on much larger scales, such as galactic history. Why do we think so? Well, the absence of clear evidence of extraterrestrials capable of collecting learning suggests that human beings may be unique on a galactic, even perhaps a cosmological scale. He of course, tempers that by noting that we are yet to meet extraterrestrials. So it's not a clear-cut argument, but certainly it leads us to be very aware of the fact that collective learning may be extraordinarily rare. And perhaps, complex human modern societies arise close to the limit of our universe's capacity to generate complexity. That's an interesting position to take, because he earlier argues that the capacity for complexity the upper limit seems to be moving up. And it suggests here, he's suggesting that there might be a limit to that limit, close to the limit. Perhaps it's close to the current limit, because I think it's very egocentric of human beings to try and cap a limit. It's simply that the kind of limit we're looking at may be reached, because to go much beyond that will actually lead to planetary collapse. Maybe different forms of collective being and learning are yet to emerge. But one thing's for sure, that at this stage in his paper, which is towards the very end, it's the second last page that this comes from, Christian is indulging in what we could call futures thinking, where he's speculating, he's reading into the future from our current context. And now he concludes, or restates with the conclusion that he gave us at the beginning, the modern creation story. Well, what is that? Well, that's the story of evolution. It's the cosmological story. That's what the modern creation story is. It combines cosmology with Darwin's theory of evolution and natural selection. It does not necessarily deprive human beings of meaning and significance. From some points of view, the modern creation story suggests that humans are remarkable unusual and profoundly important. On the map of complexity, then, humans are essential as they were within most traditional cosmologies. So cosmologies tell us meaningful stories, and that's something that we need to understand as a byproduct or an epiphenomenon of this particular reading. It's saying that this is the most profound story that we can lay our hands on within our current worldview, our current paradigm. But we know that there were other paradigms, and there are other paradigms running alongside ours. Paradigms that offer us naturalistic or ritualistic or institutional religious stories of being. For world historians, then, he sums up this conclusion, namely that humans are essential, okay, to the traditional to our cosmic story. This conclusion is full of significance. It suggests first that world history, the discipline that studies the history of human beings, has significance across many scales, from the cosmic through to the microcosmic, you could say, and well beyond the conventional boundaries of the history discipline. So it's something new in history, this thing we call world history. It also suggests why compiling world history is extraordinarily difficult. Because what are we going to do? We're going to tell the story of this and that, this civilization, compare it to that civilization. No, we have to actually approach the whole thing, the whole question of the human journey from a totally different perspective. And that's what this course is trying to map out for you. Constructing a coherent story of a species as complex as ours is a challenge, okay, as daunting as any in modern science. So we've got a fascinating area that's really just emerging, that you and I are all sharing in the creation of, really. Because if even a few of you go on to take world history to its logical conclusion in your own areas of study, you know, it's you're going to be adding to this cosmological story. So, writing and beyond, I find this was interesting. One of the very last things that Christian notes is yet the argument of this essay suggests that writing world history, or writing it well, may also require a serious attempt to see the history of our species in the context of other stories, including those of our planet and our universe. What struck me about this was that Christian used the word writing. He's still very much accepting the text-based nature of traditional history. But in a sense, we can understand that another domain of world history is actually the consciousness that goes with it. That you may all, as students, you may become historians, but you also may very likely lead many other wonderful and interesting life journeys. That you can take the idea or the consciousness of world history so that we actually embody this new form of story, this new form of thinking. Whereas I can still see that Christian is still locked into the disciplinary paradigm. Of course, that's shaped his world because he's a highly regarded Russian historian in the traditional sense. So I hope that this overview has been helpful. If you want to get a taste of Christian's further work, okay, have a look at this great TED Talk. I wish to thank you very much for joining me.